I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that. Spitting slow, spitting fast. I could roast, I could gas. Think I'm okay at last, but I don't know if that can erase all the past. And the pettiness, a reflection of the emptiness. Hilarious, you think you're worth my time, you're delirious. Mysterious, because you hide behind a fake exterior. Inferior, you know I'll always be a bit superior. Get off of me, this ain't no humble brag. I want you to hear words, you can say them back. I want you to feel free from the chains at last, and to believe in what you got, it was built to last, yeah.
Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Gonna learn the consequence of being incompetent. Mental health.
Working with data and learn to use the Xcode integrated development environment to speed up your workflow.
For your final project, you will create a well-designed, high-performance iOS mobile application for your portfolio, complete with interactivity, to showcase during your job search.
You'll also be ready to collaborate with other developers, as you will have learned to use Git and GitHub for version control.
If you're hoping to operate independently or in a smaller team, not to worry. We've also got you covered when it comes to the basics of user experience.
You'll learn how to research a user's needs, create wireframes using popular industry tools like Figma, and design interactivity.
In the final course, you will prepare for the coding interview. You'll practice your interview skills, refine your resume, and tackle some common coding challenges that typically form part of technical job interviews.
Once you complete the program, you'll get access to the Meta Career Program's job board,
a job search platform that connects you with over 200 employers who have committed to sourcing talent through Meta certificate programs.
Who knows where you'll end up? Whatever the future of Connection looks like, you'll be part of its creation. Let's get started.
Hello and welcome to this course on iOS mobile application or app development. Mobile technology is everywhere. Almost all of us have encountered and interacted with mobile technology at some point, from cell phones and tablets to wearables like watches and even household appliances. As the use of mobile technology increases worldwide, so too does the demand for mobile apps. Apple's iOS is one of the world's most popular mobile operating systems, with millions of users using Apple devices powered by iOS. As such a popular and powerful platform, iOS is integral to mobile software development. This means that learning how to program for Apple devices and develop iOS apps may be invaluable for you in your development journey. So, in this course, you'll learn about the tools and resources available to you with iOS and how to use them to develop your own mobile apps. Now that you've been introduced to the program and have more insight into the role of a mobile developer, you'll consider what you hope to learn in this course, review the course syllabus, and receive some tips for successful learning, set up Xcode, the developer toolset and environment that you will use to create iOS apps, and explore the concepts of mobile apps, mobile operating systems, and iOS platforms. Then you'll gain insight into some of the fundamental components of iOS mobile PP development. This includes the key features and functions of the development tool iOS Xcode, programming languages supported by Xcode, with an emphasis on Swift, the language you will use to create your own project for this course, Xcode project templates, and the project structure of iOS apps created in Xcode. Next, you will enrich your iOS development knowledge through learning about tools in Xcode called simulators and operating system images, which are an important part of mobile app development and testing. You'll also gain insight into the build system used to create the project structure of an iOS app in Xcode and the folders and files within that structure that are fundamental to creating a successful app. After that, you'll learn about the important components of setting up an app project in Xcode, such as outlining the requirements of an app and selecting an appropriate template. Lastly, you'll learn about starting and building an app project with Swift and get the chance to create an operational video app player. If you've encountered new technical words and terminology in this video, don't worry if you don't fully understand them now. Everything you need will be covered during your learning, with each lesson made up of video content, readings and quizzes. There are many videos in your course that will gradually guide you through your learning. Feel free to watch, pause, rewind and re-watch the videos until you are confident in your skills. The course readings will help you consolidate your knowledge. You will be able to self-check your learning progress with knowledge quizzes along the way and put your skills into practice with a course exercise. To be successful in this course, it's helpful to commit to a regular and disciplined approach to learning. Although it is an online self-paced course, you need to be serious about your studies and, if possible, map out a study schedule with dates and times that you can devote to attending the course. In summary, this course provides you with a complete introduction to iOS mobile app development and will set you on your way toward professional certification and a career in iOS development. Be sure to also check out the other courses in this learning path. Looking forward to working with you on your learning journey. Over the past few decades, the number of applications or apps being built has grown rapidly. But have you ever wondered who is responsible for developing such apps? Well, they're referred to as mobile developers. With the demand for mobile developers projected to grow exponentially in the next few years, I'm sure you're interested to know more about the role of a mobile developer. In this video, you'll learn all about that, including the responsibilities of a mobile developer, the kinds of languages and skills mobile developers have, and where mobile developers work and their job roles. So, what kinds of things does a mobile developer do? While no two roles are the same, there are many common tasks and responsibilities shared by all mobile developers. First is designing, building and maintaining mobile apps. This includes tasks like building a user interface or UI based on design specifications, writing code to support functionality, and building animations and transitions to provide an engaging user experience. Other common tasks include integrating third-party application program interfaces or APIs to connect the app with other technologies or code, writing tests and releasing apps and updates to the Apple and Google stores. Apart from the many coding tasks, developers often work as part of a team, which can include other developers, project managers, quality assurance or QA professionals, and designers. In fact, as a mobile developer, you may find yourself working with multiple teams. As teams and development projects become larger, version control becomes increasingly important. Version control is a system that allows a development team or teams to track and manage changes made to the software code. Version control also allows your team or teams to work simultaneously and collaboratively on projects by enabling access to the most recent version of the software code. GitHub is one online platform that can assist you with version control. Amongst other things, GitHub makes it easy for you to keep track of your work and others' work and review code changes in collaborative projects. It allows you to access and navigate between different versions of online files. Mobile developers also often play a role in planning projects and participate in the project progression by attending regular team meetings. In addition, you'll find that almost all mobile developers spend some time researching their projects and keeping up to date with emerging trends regarding their operation system. Because many of a mobile developer's tasks and responsibilities involve coding, it's essential for them to know the language that their app's operating system or OS software development kit is built upon. Swift and Objective-C are programming languages for iOS app development. Being proficient in these programming languages can make you more capable as a mobile developer and can expand your choice of job roles and projects. Other valuable skills for any mobile developer who builds the user interface or UI for mobile apps are design and user experience or UX, as well as knowledge of server technology and continuous integration or CI. This is the practice of automating the integration of code changes from multiple contributors into a single software project. Okay, let's say that you've mastered your mobile development skills. Where in the job market do you find work? Well, because mobile development skills are in demand, there are many roles available. For instance, there are many developer roles in a large company such as Meta. As the creators of React Native, mobile development is very important to Meta. Anyone considering a position at Meta will understand that knowledge of the React Native framework is a common requirement for their software engineers. Now let's explore some of the available job options. Mobile development is popular with small companies and startups who understand how apps can aid their growth. It is equally useful to large companies. For instance, they may want to build apps that help them gain a slight competitive advantage, foster engagement with their user base, or allow their customers to quickly access their products and services. You can also use your skills to work as a freelance mobile app developer. If you're not attracted by any of the many job offers available to you, you may prefer to start your own development company. With mobile development, you can take your own ideas directly to the market. You should now have a clearer understanding of the role of a mobile developer, their responsibilities, and the skills they require.
iOS is unique in that it's really a clean and slick system. And once you have built it, you have the power to get your work out into over 1 billion people's hands. And that is something that's really exciting. With a little bit of effort, you can just have that level of impact. My name is Arunava, and I am an iOS developer at Meta. You may have used some of the products that I have worked on, including Messenger, Facebook Live, Facebook Search, among many others. Right now, for me, as a product engineer, I spend a considerable amount of time in meetings with managers, product managers, designers, in the innovation process of how we want products to look, designing and coming up with new features. Depending on the projects I'm working on, I also spend a considerable amount of time writing the code that we send out and building those features. I also spend a lot of time coaching junior engineers and new engineers, or when I have interns, helping the interns kind of find their own footing and build whatever they're working on. And of course, I also spend a lot of time just having fun with my team, organizing game nights or just going out and having fun with them. At Meta, when you finally complete a project after so much toil and hard work and consideration and deliberation and debates, and you see it really going out into the hands of the users, and you hear back saying that they found it useful or people are using it or they've come to rely on it, or even if it was just fun, I think that's definitely the most rewarding part of the job. It's lots of little things like checking for data, making sure things don't go down, monitoring bugs, fixing bugs, which may not be as glamorous as writing shiny new features, but as with any glamorous job, this job is not immune to those things as well. Technical skills that are most key to being an iOS developer, as with any software engineer, honestly, would be problem solving, coding, and design. Problem solving is key to figuring out how to tackle these gargantuan issues that you have. A lot of the problems that we solve are things that no one in the world in history has tackled before. So to be able to kind of labor through that, work with everyone and figure out what we're going to do, that requires a lot of problem solving skills. Coding is almost the language of how you do that. Coding is the medium through which you actually really finalize and get those solutions to the problems out there into your product. While there's a stereotypical image of engineers just coding away all day, the truth is that in engineering, you need a lot of working with other people, talking to your teammates, other stakeholders, sometimes across teams, to make sure everyone is aware and the whole process moves efficiently and smoothly. For planning, you want to know that you're committing the right dates, you're solving the right problems, because there's so many things to solve. Sometimes we miss the forest for the trees. So there is that issue of making sure you're planning the right things, scoping, making sure you have the right dates on the schedule. That's very important to make sure you function correctly as well. Lastly, mentorship. As you grow more senior, all these technical skills as well as soft skills, it becomes your responsibility to pass that on to that next generation. So being a good mentor and having that ability to coach other people also comes really in handy as you grow more senior in your career. iOS is a really cool and versatile platform to build on, and it really gives you great output as well. So try looking at some of the existing patterns and existing really cool apps and designs that you may enjoy yourself on your device, and try to replicate some of those. How does this gesture work? How does this animation work? I think some of those really give you things beyond any course as well, and give you the building blocks with which you can deliver really cool products yourself as well.
As you progress through this course, you'll have the opportunity to create your own project in the development environment called Xcode. So let's take a moment to download and install Xcode now and briefly explore project creation. In this video, I'm going to demonstrate how to download and install Xcode on macOS. First, visit the official webpage for Xcode, developer.apple.com/Xcode/. Note that you will need an Apple developer account to download from the website. Click the download button on the top right. To download Xcode from the website, click Website. You can also choose to download Xcode directly from the App Store. An Apple ID will be needed to download from the Mac App Store. The downloads page you are taken to after choosing Website has different tools apart from Xcode. However, they are beyond the scope of this video. You will notice that there are different versions of Xcode available. Currently, the latest version is Xcode 14 Beta. Beta means that this version is still in development. Although you can use this version, I'd recommend that you pick the latest stable version of the Integrated Development Environment, or IDE. So, to select Xcode 13.4.1, click on View Details. You can then download the xcode.xip file. This may take some time depending on your internet speed. Once downloaded, click on the .xip file to extract it. Then you'll be prompted to move Xcode to your Applications folder. Your last step is to open this version from the Applications folder and follow any installation instructions that follow. Now that you've downloaded and installed the IDE, let's preview the environment and how to create your own project in Xcode. On the Welcome page for Xcode, you have 3 options. You can create a new Xcode project, you can clone an existing project, and you can open an existing project or file. For this video, let's click Create a new Xcode project. In this window, you are presented with different templates for your project. This allows you to get started with projects quickly. Select the App template for iOS and then click Next. On this page, you are required to provide a name for the product you are building. Let's call it Hello_World. The Team option enables you to add any team members to the project, which means developers will be able to collaborate. You can do this by clicking the Add Account button. The next fields are the organization and bundle identifiers. These are used to uniquely identify you or your team and your application in the App Store. After that, you can choose between SwiftUI or Storyboard for your interface. Let's select Storyboard for now. Finally, you can choose between 2 languages, Swift and Objective-C. Select Swift as this is the language you'll be using throughout this course, and click Next. A window will open in which you can choose the location on your computer to create your new project. An important step here is unchecking the source control option, as you won't require source control at this stage of your learning. Then click Create. The environment for your Hello_World app is displayed. The project pane, which gives you access to the project files, is on the left. In the top bar is a play button. The button is used to run a simulator. This will be important for you when you create your own project later, as it allows you to simulate your app without needing to install it on an actual physical device. You can click on the button to run the current test project. Another window will open with the simulator. In later videos, you'll learn more about how to configure simulators and how to use them efficiently. With Xcode installed and some insight into project creation, you're ready to jump into iOS app development. With billions of mobile users across the globe, mobile apps play a more significant role in the way people access information than ever before. While many businesses distribute software products on multiple platforms, such as web and mobile, not everyone has the resources needed to build multiple solutions. In such circumstances, and with the number of mobile users now surpassing desktop users, businesses may understandably choose mobile apps to reach their target audience. With the demand for mobile apps increasing, it's important to understand what mobile apps are. In this video, you'll learn more about mobile websites and apps, as well as the advantages and disadvantages of developing mobile apps. A mobile website is a website designed, developed, and optimized for mobile devices only. While mobile websites are designed to display and work on major browsers, they still require an internet connection and don't take advantage of the unique functionality of a mobile device. That's where mobile apps come in. A mobile app is installable software that runs on mobile devices. Mobile apps use a device's hardware and software features and usually provide an efficient, more intuitive and seamless user experience. When choosing to develop a mobile app instead of a mobile website, one way to decide is to ask yourself this question. What specific actions do you expect your product to perform? For example, if you don't need your users to perform any operations and your product is mainly content-driven, then you may opt for a mobile website. But if you want users to perform actions that will require the device's hardware, you will need a mobile app. It's also helpful to understand the pros and cons of mobile apps when deciding whether to create one. The first advantage of mobile apps is that they are faster than mobile websites. They can also access the device or system resources, such as a location or Bluetooth, and can work without internet access. That said, mobile apps can be quite expensive to build and more difficult to maintain when compared to mobile websites. Another disadvantage is that for a mobile app to be compatible with different platforms like iOS and Android, it is often required that it be built from scratch. It may also be difficult to have your app approved by the App Store if it does not meet specific requirements. You've now been introduced to mobile apps and the advantages and disadvantages of developing a mobile app compared to a mobile website. As you learned earlier, mobile apps are vital in the mobile development space, so I hope you're looking forward to creating your own app as you progress with your learning.
At Meta, we have a lot of in-house developed frameworks and libraries for iOS development, such as ComponentKit, that make developing these iOS apps much quicker, much faster, and easier. And in fact, these are open source as well, so you can use them even if you're not at Meta. My name is Arunava, and I am an iOS developer at Meta. At the company, we usually have organizations broken down first at the app level, for example, Instagram, Messenger, WhatsApp, Facebook, and then it's by greater product level, for example, feed versus videos, and then the specific team level, so live video or Instagram Stories player. Within these teams, we have iOS, Android, web engineers. Because we want to maintain consistency across platforms, everyone works very tightly together and with the cross-functional partners as well towards a common goal or mission. So when we want to build something new or work on a new project, at first we set goals for what we want to do. For the app or the feature, do we want to grow it? Do we want to spread awareness about it and improve it? Do we want to change how it looks and feels? Do we want to make it more reliable? That's important in knowing what we actually want to do. Once we have that goal set, we have a brainstorming session, sometimes the whole day long, where we have not just all the engineers, but product managers, engineering managers, all the cross-functional partners coming into the same room and just spending some time in workshopping and coming up with these ideas. And anyone can come up with these ideas. Once you have all these ideas out there, we usually vote on which one's the most feasible, which one's the most impactful, and we filter out the ones that make the most sense, that make the roadmap. Once we have this roadmap, we start other things like privacy reviews, scoping, and planning for the project and what it's going to look like. And then once execution starts, we have milestones which we hit along the way and fixing bugs and testing it along the way. Now, once execution is complete, what we do is we roll out the experiment. And in the experiment, we monitor how users are responding to this feature. If we see that the experiment is not performing as well, we ask ourselves the questions. Why is it not performing as well? Is it not clear to users? Can we make it better? Is it not working the way we intend to? Is there a bug somewhere? If the answer to any of those is yes, then we go back, iterate on that, and then launch another experiment with those fixes and improvements. We keep doing this as many times as needed until we have confidence that we've done all the best that we can. If it still does not work out or doesn't fit or users don't like it, then we sometimes abandon that experiment. However, we record the learnings because sometimes even an experiment or a test that doesn't launch but gives us good learnings is considered a success. On the flip side, if we do see that the experiment was a success and we got good metrics and achieved our goals, that's where the fun part starts, because then we start rolling out the feature slowly but steadily to users across the world and wait in anticipation for how they feel about it. One of the challenges that comes with working on these new apps is that you don't really know what a good answer is because no one has answered it for you before. There's no established playbook as such that you can follow. So often we have to come up with the answers on our own. And sometimes the answers we have are wrong, even if they seem like they are the right answer. So that is a process that we sometimes have to get accustomed to, assuming that we have good intent, but we don't have all the answers. If someone says, we should make the like button green, to someone that might sound ridiculous, but to someone that might sound like a great idea. Ultimately, it's what the users want and like that give us the answers. Of course, we have some principles, and our tech stack has its own guidance that we have to follow, and we have our design principles as well. But outside of that, we want to give the best product possible to our users. Even if we fail fast, and then we keep going until we find the right answers as a team. As you get into iOS development, remember that if you join a team, whether it's a small team, a big team, you always have that team to support you. Nobody in this company works in isolation, and the key is always to believe your team and work together, as we do, in building our products. While iOS development might sound monolithic or just like one thing, it can be very varied depending on where you want to take your career and your specific interests, not just technically, but outside your technical interests as well. Hey, my name's Arunava. I'm an iOS engineer at Meta, and I've built a lot of the products that you might have used, including Messenger, Facebook Live, and Facebook Search. Within these different platforms, there are some differences. For example, Android has more phones globally, but iOS has much more of a presence in US, Europe, among other places. Many companies also find iOS to be a key part of their strategy because it brings in a lot more revenue. It also depends on the geographic location of where you are, whether there's more demand for iOS or Android. But if you're looking for a longer career in mobile development, most companies are going to look for iOS or Android specialists. The reason behind this is while cross-platform development is super useful, it's often very difficult to get the level of customizability or performance out of it as a specialist could. So that's why if you're looking for more of a career at a larger company, or even sometimes startups, they will ask for having an Android or iOS specialization. What exactly you do can differ based on which context and what kind of company or what kind of project you're working on. For example, an app or feature that focuses on videos might focus more on media playback and how that whole performance works, how to get it quicker. Whereas if you're working on a finance company or a media company in the technical side, they may have smaller scope based on what they want to work on. Working at a large company and small company also has its differences. At a smaller company, you may need to supplement your coding skills with building infrastructure and ramping up other younger engineers in trying to hire and grow your company. Whereas at a larger company, you may be able to zone in more and focus on a particular set of your technical skills that you find most rewarding. Sometimes larger companies also have a lot of frameworks and libraries that make things much faster. At Meta, for example, we have lots of plugins and frameworks, including ComponentKit, that makes things just a lot smoother for us, whereas smaller companies may rely more on building with the bare blocks. Initially, when you start out as a junior engineer, you churn out a lot of code, learn different projects, how to build on those, how to iterate those, the whole system. And then as you grow more senior, you transition into being more of a leader and teaching other engineers how to do those things, showing them the ropes and increasing the scope and influence that you have. The way you do this can depend on what your interests are. You may want to be a generalist, which is someone who works on a broad variety of things, both product and technical, and have impact all around the board. You can choose to be a specialist where you deep dive into a very specific skill set and focus on being an expert in that and go around consulting people on whenever they want to use something in that skill set. You could choose to be a fixer, which is somewhat similar to a specialist, but you build this specific skill set and it's almost a freelancer type role where you go around different systems, delivering wins all across them and even fixing some things for them along the way that no one else might have been able to do. If you're interested in product, you could work a lot more with product managers, designers as a product hybrid and be in the room when there's a lot of innovation going on and planning going on and be a part of that as well. You can also be a coding expert and focus on churning out thousands of lines of high quality code. You won't be involved as much in the planning or scoping, but if you do enjoy coding, you get to do that all day, every day, as much as you want and keep churning out the volume of code maybe no one else could have. The possibilities honestly are practically endless, and it depends more on where you want to take your career. At Meta, we use the term strengths a lot, not only to mean something that you're skillful at, but something that you enjoy and you derive strength from. So what is your strength? You don't need to have the answer right now, but as you go through your career, you will often be thrust into different roles and different projects that give you exposure to these different things. Sometimes you'll be building the building blocks that other engineers use to build larger products. Sometimes you'll be building the product itself that the end ends up going into the user's hands. Try all of these different things out, and over time, over the years, you will learn which ones you enjoy the most and which are your strengths. I hope this video gave you a bit of understanding of all the different roles that you can go into with these skills, and perhaps some of them would be interesting to you as well once you start this amazing career that you have in iOS development.
If you're looking to build iOS applications or apps and position yourself in the mobile technology industry, then it's essential that you're familiar with the different programming languages you can use. In this video, you'll be introduced to two iOS languages, Objective-C and Swift. You'll also learn about the benefits of using Swift, the language you will use in this course. In the world of iOS development, Objective-C and Swift are both extremely popular programming languages. Objective-C was originally developed by Brad Cox and Tom Love in the early 1980s. For a long time, iOS developers used Objective-C to develop iOS apps because it was the only supported language. However, iOS eventually needed a more modern language to complement the features of Objective-C. This need inspired the development of Swift. Swift is a general-purpose multi-paradigm that was introduced by Apple in 2014 and is now a supported language in Xcode, the development environment for Apple's operating system. Multi-paradigm means Swift supports multiple programming paradigms, for example, object-oriented programming as well as functional programming. In fact, since it was announced as the official language for iOS, Swift has become the preferred language for building iOS apps. That's one of the reasons you'll be working with Swift in this program. Now, let's take a moment to discuss some of the reasons Swift is the preferred language. First, Swift is fast. This comes as no surprise, considering it was developed to tackle performance. According to Apple.com, Swift is almost 3 times faster than Objective-C and just over 8 times faster than Python. Another benefit of Swift is its scalability. This means you can easily and effectively modify Swift code. Apple is also more likely to provide more support for Swift than Objective-C in the future. Lastly, Swift is safer. Unlike Objective-C, Swift has a strong typing system and error handling, which prevents occurrence of code crashes and errors in production. You have now been introduced to 2 iOS programming languages, Objective-C and Swift, and should have greater insight into why Swift has become the preferred language for iOS. Keeping in mind the benefits of using Swift, I hope you are looking forward to working with this programming language when creating your own project for this course. When you start creating your own mobile applications, being aware of ways to create effective apps efficiently will become invaluable. One way to speed up development is by using project templates. In this video, you'll be introduced to the Xcode project templates that can be used to quickly create new iOS app modules, activities, or other specific components of your project. As you can imagine, the ability to get started quickly with app development is one of the things developers look out for when choosing a development environment for writing code. The industry standard way of developing any application is to use an IDE, Integrated Development Environment, which is capable of supplying all the tools and features needed to speed up development. These programming environments also supply a code base or starter code for several types of app development, which can also give a sneak peek at what the language has to offer. Xcode, an IDE used for developing applications for Apple devices, provides starter code for various basic implementations of the iOS platform. You can select from the wide range of templates that follow specific design principles and coding best practices to quickly create functional apps. Let's explore a few of the templates available on Xcode IDE, namely the app template, the game template, and the sticker or iMessage app template. The app template allows you to create a basic app project for various platforms, such as iOS and watchOS. With the game template, you can create games in less time using Apple's Game Software Development Kit or SDK, such as SpriteKit or Metal. The sticker and iMessage apps aren't apps as such, they are more like plugins that can be used within existing apps. It's more efficient to use these apps because they usually come with special and helpful configurations. Apart from these templates, you can select other templates such as Framework, Metal Library, and more. Although these are not complete app projects like the templates mentioned earlier, you can use them to create an exportable library or framework that can be used in multiple projects, including open source projects. Now that you know more about project templates, let's outline some of the benefits of using them. The first advantage of using project templates is that they offer a clear understanding of the project structure. The templates provide you with a structure that meets the best practices recommended by the operating system or OS manufacturer. Next, as mentioned earlier, project templates give you a preview of what the platform has to offer. This way, you can get insight into how things work behind the scenes before investing your time in learning how to build apps for that platform. Last, but certainly not least, project templates allow you to build quickly. You can start building apps in minutes by using inbuilt project templates. You should now understand what project templates are and be able to list some of their benefits. You've also been given a sneak peek at the kinds of templates available in the Xcode and can look forward to learning more about what this IDE has to offer you as a future developer. As the mobile market continues to grow and with the demand for apps increasing, app development has become a lucrative business. In fact, it is anticipated that this market will soon be worth over $300 billion. To successfully join this industry as an iOS mobile app developer, you need an understanding of the tools and technologies required to create apps efficiently. Over the next few minutes, you'll be introduced to one of these mobile development tools, iOS Xcode. Apple launched Xcode in 2003. Since its launch, many developers have chosen it as their preferred environment for app development. Xcode is Apple's official integrated development environment, or IDE, for building apps that run on iOS and other Apple OS apps. It provides developers with features that improve the development of their apps and the overall quality of work. Xcode supports various languages for app development, such as Objective-C, Swift, C++, and more. Some of its key features include a complete build system, which will allow you to compile and build your Apple OS apps, a fast emulator used for testing apps, developing apps for different types of Apple devices, free project templates for quick development, and support for third-party integrations. Xcode enables developers to deliver high-quality apps within a single environment with its essential tools. These key functions of Xcode include the toolbar, navigation area, editor area, utility area, and debug area. Let's explore each of these key functions by taking a tour of iOS Xcode. The toolbar provides a wide range of actions, such as running your app on a simulator or physical device. The navigation area allows you to navigate and access project files. It gives a sleeker view of the structure visible in the project window. The editor window allows you to make changes to code. This is dependent on the existing file type. The utility area has a variety of inspectors to view the details of the file, element, or piece of code that you're working on. Finally, the debug bar displays the status of your project and the IDE itself, as well as any warnings or messages. In this video, you learned that iOS Xcode not only supports various languages for mobile app development, but also includes features and functions that will aid you as you start developing your own apps. When starting your career as an iOS developer, one area you will need to understand is how iOS projects are created in Xcode. To help you to get started, this video will serve as a quick guide to creating your first iOS project. Although this integrated development environment, or IDE, is designed to perform several operations beyond just creating projects, the focus of this video is how to use Xcode to start your project. An iOS project contains all the files that your IDE will need to build and generate your iOS app. With the Xcode Software Development Kit, or SDK tools, it's easy to start a new iOS project with a set of default project directories and files. Keeping that in mind, let's explore how to create a project in Xcode. To start a new project, click on Create a new Xcode project in the Welcome to Xcode window. Another window pops up, giving you the option of various platforms and templates for your new project. For example, you can choose between multi-platform, iOS, macOS, watchOS, tvOS, driver kit, and more. I'll leave the selection of iOS, as this platform is the focus of this course. You can also choose between various templates for your iOS project, from app and game to iMessage and Safari extension app. Let's select App as a template by clicking on App, then click Next. You now need to define various aspects of your app project, starting with a name for your app. Let's name the project Hello World. Then the creation of a team account is offered. You can omit this for now because there is no team, but in the future you can add an existing account if you have one for your development team. Next, you can add an organization identifier. You can use your organization's domain name for the organization identifier to ensure it is unique. I'll accept the default entry for now. Following this is the bundle identifier, which is the organization identifier combined with the project name. This functions as a unique identifier for your app and is assigned to your project in the App Store. After that, you can define the interface you want to use. You can choose between SwiftUI and Storyboard. SwiftUI is a simple way to build user interfaces across all Apple platforms. Storyboard allows you to lay out and design the UI of your application by adding views, such as buttons. Let's select Storyboard for the purpose of this video. Finally, you can choose your language. Choose Swift, as this is the language that you will use in this course. Once you have defined all the necessary fields, you can click on Next to create your project. The project, Hello World, is now displayed. The project pane is on the left-hand side, with project files and folders for app development. You now know the steps for creating a project in Xcode. Why don't you give it a go on your own? You should now know how to launch a new project in Xcode, a fundamental first step in creating your own iOS apps in the future. You are now ready to move on to exploring all the project files generated by the Xcode environment and how you can use them when creating your very own project. Mobile apps have become integral to everyday life for most of us. In fact, there are millions of iOS apps with wide-ranging purposes available for users to download. But as an aspiring mobile developer, you may be wondering, what are the different components that go into making these iOS apps? Let's find out by exploring the anatomy or structure of an iOS app. An iOS app is made up of 4 major components that serve as the building blocks of any iOS app in the market. Each component has its own purpose and unique behavior. These major components are UI application, UI application delegate, user defaults, and view controller. Let's unpack each of these major components in turn. The UI application is an iOS application's starting point and is responsible for initializing and displaying your application's window. It is also responsible for loading your application's first view into the window. Every iOS app project comes with a UI application component. During app launch, once the initial setup, such as locating and loading app binary code and linking necessary frameworks is completed, the system must call into the binary code to start it running. Every iOS app has only one instance of UI application, and without this component, it's impossible for an iOS app to run successfully. The UI application delegate is a set of methods to maintain the overall shared behavior of your app. This delegate can be referred to as the root of an app. It works in conjunction with the UI application to manage every communication with the operating system. Imagine you need to configure your app to receive notifications. This delegate allows you to register for any required services at launch time, such as Apple Push Notification Service. There are cases where you are required to save data from the app to a file locally. This is where the UI document comes in handy. The iOS UI document class is designed to provide an easy-to-use interface to create and manage documents and content. While UI document is used for handling local file systems, such as a read and write operation of data in the app background, its purpose is primarily to ease the process of storing files using iCloud. The UI view controller is the basic building block of your iOS app. This component oversees the activities that happen on screen, from user interfaces to animation, from interaction to navigation, and more. In simple terms, the UI view controller defines the shared behavior and properties for all types of view controller that are used in the iOS application. A view controller is a container on which the content views are drawn to create an iOS app. Now let's examine the anatomy of an iOS application. I'm going to demonstrate the structure or different parts of an iOS app by using a previously created project called Hello World. The Integrated Development Environment, or IDE, is currently displayed on screen. On the left-hand side, the project pane displays the folders and files available for the Hello World project. Within the app project, there is the main project folder and 2 folders for tests. You can click on the app project hello_world at the top of the project pane to configure your app. The configuration options are displayed in the IDE as tabs. For example, the first tab, General, is related to general configuration. There are many things that you can specify in this environment to ensure your app runs seamlessly. For example, the display name, bundle identifier, version number, and build. The next configuration tab is Signing and Capabilities. When you deploy your application to the App Store, you will have to configure these things. You'll learn more about this and the other tabs available for configuration while you are developing your application in later lessons. Within the app project hello_world, there are other folders and files. The first folder is the main project itself. This is where you write the business logic for your project. In other words, the functions you want to build. When you expand this folder, it displays several files that you were introduced to earlier in this video, like App Delegate and View Controller. The main file is the view where you can create the components for your app. The view controller is used to control the behavior and interactions on this view. The next folder is called Hello World Tests. This folder is used for unit testing, meaning this is where you test your application end to end. You will learn more about testing at a later stage. That's a brief overview of the structure of an iOS app in Xcode. As you progress, you will learn more about structuring and developing a project in Xcode and why the different features are useful and how to use them. You now know more about the major components that make up iOS apps. Well done, you're making great progress towards creating your very own project in Xcode. You've reached the end of this module on Introduction to iOS. In this module, you've been introduced to the role of an iOS developer, discovered the basics of mobile apps and platforms, received an intro to iOS mobile app development, exploring iOS languages, project templates, and app structure. It's now time to recap the key points and concepts you learned and skills that you gained. You began the module with an introduction to this iOS development course. During this lesson, you learned about the responsibilities, skills, and job roles of mobile developers, downloading and installing the iOS development environment, Xcode, and creating projects in Xcode. You were then introduced to mobile platforms. The lesson focused on the basics of mobile apps, mobile operating systems, and iOS platforms. Following the completion of this lesson, you should now be able to explain what a mobile app is, outline the advantages and disadvantages of developing mobile apps compared to mobile websites, and discuss real-world examples of mobile apps at Meta. You can now also provide a high-level overview of how mobile operating systems like iOS work, identify different iOS platforms, and outline the careers available in iOS development. In the final lesson of this module, you explored iOS mobile app development. Now that you've reached the end of this lesson, you can briefly describe the iOS programming languages, Objective-C and Swift, and the advantages of using Swift, and discuss Xcode project templates and their benefits in mobile app development. You should also be able to outline the key features and functions of iOS Xcode, a mobile development tool, demonstrate how to select and launch a project in iOS Xcode, and provide a high-level overview of the structure of an iOS app created in Xcode and the role of its various major components. You're now familiar with the basics of iOS mobile app development. You can explain what mobile developers do and what mobile apps are, and have a knowledge of different iOS platforms and project templates, as well as the iOS operating system and languages. You know more about iOS Xcode and can outline the basic structure of an iOS app created in Xcode. That's a great start to your iOS development journey. Well done. With billions of mobile devices around the world, the demand for and use of mobile devices is high. As more new devices are released to the market to meet this demand, software engineers need to develop apps for them. As you can imagine, purchasing different types of devices to test these apps is not practical. That's where simulators come in. In this video, you'll learn more about simulators, their purpose, as well as the types of simulators available. So, what exactly is a simulator? A simulator is a computer program that's designed to simulate another kind of device. While different types of simulators have unique ways of operating, the overall goal remains the same: replicating the experience of the original hardware or software. By mimicking the behavior of mobile devices, simulators allow you to test how your apps will run on the devices you've designed them for, without having to install them on the actual physical devices. For example, if you are an Apple user and you want to run an app specifically designed for a Windows computer, you will need to use a simulator. Simulators do, however, require high computing resources in most cases. This means that if you are going to use a simulator on your machine, it's important to make sure there's enough storage space and random access memory, or RAM, available for it to run effectively. And what types of simulators are available to you? There are several commercial and open source simulators available for most of the operating systems in the market. Let's discuss some examples. Simulators like BlueStacks allow you to run Android apps on operating systems like Mac and Windows. Appetize.io, a browser-based emulator that allows you to use iOS applications on any PC. With Wine, you can run Windows applications on the Linux OS. Aside from running apps, some simulators even make gaming possible. For example, simulators like Nostopia allow you to play Nintendo games on Linux. SNES Classic console simulators, which are standalone, allow gamers to play old video games on modern HD televisions. Lastly, many PlayStation Portable simulators allow users to play games made for other consoles on Sony's mobile system. You should now have more insight into simulator software, what simulators do, and the different types of simulators available to you. Later, you'll learn how to configure and create a simulator in Xcode, which will allow you to simulate your own project app. Because running an app on a simulator is much like using an app on an actual mobile device, most developers are turning to simulators as a tool to test and even debug their app code. While simulators are a safe place to test code, especially at the beginning of the design phase, using a simulator on a computer does require some configuration to function properly. In this video, you will learn exactly how to do that: configure and launch a simulator. You can configure a simulator with the help of the Devices and Simulators feature in Xcode. More specifically, you can specify the interaction between the development computer and the simulator with this tool. Let's explore how to start a simulator in Xcode. When launching a simulator, you'll start in the Xcode environment. In the toolbar, click Window and then select Devices and Simulators. Once you click that, you will be presented with a wide range of pre-created simulators that come with the Xcode IDE. You can create your own version if you cannot find what you need from the list of available simulators. If you click on Devices in the top left corner, you will be presented with a list of physical devices that have been connected to your computer. Currently, no selection is displayed as there are no connected devices. Let's go back to the simulators. To create your own simulator, click the plus button at the bottom left-hand corner of the screen. You will then be presented with another window where you can specify the name, device type, and operating system or OS version. For this video, let's name the simulator Test. You can choose a device type from a wide range of device types, including iPhones, Apple Watches, and iPads. Let's leave iPhone 6s selected. For the OS version, you can choose to leave the default as iOS 15.2, or you can click on it and then click Download More Simulator Runtimes. This will open another window where you can download a wide range of other operating systems. Because iOS 15.2 works in this case, you can just close the window for now. Then click Create. The simulator is now created and is available in the list of simulators on the left-hand side. It's worth noting that you can connect your simulated iPhone to an Apple Watch. For example, the iPhone 12 Pro simulator is paired to the Apple Watch Series 5. This means that when you run an app on the iPhone 12 Pro, it's going to simulate the Apple Watch. So the experience you have on an iPhone is going to run on an Apple Watch as well as in real time. Let's get back to the test simulator. You can click on it to perform various functions such as renaming or deleting it. So how can you start your simulator? To launch a simulator, you can click the Xcode icon at the top left of the screen. Then select Open Developer Tool and click on Simulator. It will launch one of the simulators by default. With the simulator activated, to change the simulator, you can select File, followed by Open Simulator, and then hover over iOS 15.2. All the simulators that run on iOS 15.2 will be listed here, of which Test, the simulator you created earlier, is one. You can do the same thing for tvOS and watchOS, but let's click on Test. The test simulator is coming up already, and that's how you create and manage a simulator on Xcode. You should now know how to configure and launch a simulator. This is an essential skill for iOS mobile app development, as you will likely use simulators to test and debug your own apps in future. With the release of each iOS version comes new changes that offer security and performance improvements and enhance the user experience of iOS overall. To make sure your app users have the best experience, it's essential to understand the dynamics of different operating systems. That's why in this video, you'll be introduced to Simulator Operating System or OS versions. Simulator operating systems are versions of iOS that you can run on a computer. With the help of these Simulator OS versions, your app can leverage the features of any operating system in the market. For example, if you wanted to test the most recent releases, you could access the most recent OS version and run it on the simulator to experience the OS. Likewise, if you wanted to test your app against an older OS, you could access iOS 10, for example, and run your app with that OS using a simulator. With OS images, you can enjoy the built-in features of different operating systems using the iOS Software Development Kit, or SDK. The most recent iOS versions available for developers in Xcode range from iOS 7, released in 2014, to iOS 15, released in 2022. More specifically, after the release of iOS 7.1.2 in 2014 came 9.3.5 in 2016 and 10.3.3 in 2017. These were followed by 9.3.6 and 10.3.4 in 2019, 12.5.5 in 2021, and 15.5 in 2022. Now that you know more about the operating systems running on Simulator, let's explore how to access them in Xcode. To start, let's select Window from the top bar and then click Devices and Simulators. This will open a new window that displays different simulators installed on Xcode. As an example, let's click on iPhone 12 Pro and then the plus button under the listed paired watches. The iPhone 12 Pro simulator is paired with an Apple Watch simulator. The operating system or OS version is listed as watchOS 8.3. When you click on that, Download More Simulator Runtimes is displayed. If you click that, it will take you to a different window that lists the multitude of operating systems that you can download. While the iOS simulators are specifically designed for iPhone devices, the tvOS category is for anything related to television, and watchOS helps you simulate your application on Apple Watch operating systems. These operating systems all come with a simulator by default, so all you need to do is download the simulator to have access to them. Take note that you must install the simulator in order to have access to the operating system that you want to simulate. And that concludes your introduction to the operating system versions available on Xcode. You have now learned about simulator OS versions and how to access them in Xcode, preparing you to use an OS image to run your own app using a simulator in the future. The Xcode simulator is one of the most widely used tools by developers. As a result, becoming familiar with the simulator interface is vital for any developer looking to develop apps for iOS devices. In this video, you will learn more about the iOS simulator interface. The iOS simulator presents the iPhone, iPad, or Apple Watch user interface in a window on your Mac computer. It provides a great way of developing your app and testing directly on your computer, rather than having to physically interact with an iPhone or iPad, for example. You can interact with Simulator by using the keyboard and the mouse to emulate taps, device rotation, and other user actions. Let's examine the iOS simulator interface. Before discussing the iOS simulator interface, let's explore the various simulators available in Xcode. To do this, select Window in the Xcode top bar and then click Devices and Simulators. A window with two tabs, one for devices and another for simulators, displays. When you click the Devices tab, it will display any physical iOS devices you are connected to. The Simulators tab displays all the simulators available to you. Let's run one of these simulators so that you can examine the simulator interface. You can close the Windows interface that's currently open. To start a simulator, you can click on Xcode in the top bar, select the option Open Developer Tool from the drop-down list, and click on Simulator in the submenu. The simulator, which was created earlier, is simulating an iPhone interface running iOS 15.2. Because it is a simulation of the iPhone interface, you have certain controls available to you, similar to the controls you'd have on the actual device. For example, you can use your mouse to scroll to the left or the right. You can also access the applications featured on the screen and the settings feature, where you can control the behavior of the application. The simulator even features a window button at the bottom of the simulated device. Once the application you are developing is up and running, it will be installed on the simulator and will display on this screen like the other apps displayed here. In the bar at the top of the iPhone simulator, you have the following three functions: Home, which is used to move back to the home screen; Save Screen, which can be used to take a screenshot of your application on the interface of the iPhone; and Rotate, which is used to rotate your device's screen. And that explains the interface of the iOS simulator. I hope you'll be able to use the simulator to run your application in subsequent lessons. You have now learned that the iOS simulator interface presents the iPhone, iPad, or Apple Watch user interface in a window on your Mac computer. You should also have a better understanding of the interface of the iOS simulator. Constructing a house should start with the foundation. This is because without a structurally sound, solid foundation, the house will likely be unable to withstand environmental factors and over time encounter serious damage. The same applies to mobile app development. When you develop an app, it's important that it is well structured using project folders. These folders hold the different pieces of the entire project together. In this video, you'll learn more about these folders, specifically the folder structure of an iOS project. An Xcode project is a repository for all the files, resources, and information necessary for an app to build and run successfully. The project contains all the elements used to create products and maintain relationships between these elements. It contains one or more targets which specify how to build products. Whenever you start a new iOS project in Xcode, it will automatically generate many files and folders for you by default. These files and folders contain everything that is required for an app to run, from source code and assets to test code and build configurations. Let's unpack some of these basic files and folders made available by Xcode. The navigation bar in Xcode allows you to navigate and access project folders and files. Let's begin by exploring the sample app folder. The sample app folder is the root directory for your project. The root directory is the root for all other folders and files. Next is the Hello World folder. This folder contains source code related to the project. Here, you write business logic code, create user interface or UI, and store assets such as images and fonts. The Hello World tests folder contains all the configurations and test files used by Xcode to run business logic tests on your project. The Hello World UI tests folder contains all the configurations and test files used by Xcode to run UI interaction tests on your project. Last is the products folder. This folder contains a generated app build ready for deployment to a device or the App Store. In this video, you learned about the folders and files that make up an iOS project in Xcode. This structure is vital in creating a successful app that ensures an excellent user experience. One of the most fundamental parts of an iOS app is the app delegate class. A class is a blueprint that defines the variables and the functions common to all objects of a certain kind. For example, a specific car model is just one of the many cars in the world. The car model is one of the class of objects known as cars. Your app will have at least one Swift class, no matter how small it is in terms of code and scalability. In fact, when you create your app in Xcode, the app delegate class is generated alongside other folders and files. In this video, you'll learn more about the appdelegate.swift file, which contains Swift code that is integral to the behavior of your app and is essential for your app to run successfully. Before diving into appdelegate, let's explore the view controller. In iOS, a view controller class, which is one thing a user can do, is an entry point for interacting with the user. This is where the action happens because view controller allows the user to interact with your app. An iOS app is usually made of multiple view controllers, sometimes called screens, that together form the user experience. These activities are represented by a view controller class whose function is to respond to user input. Each view controller class is connected to a storyboard that holds different pieces of a user interface or UI together so that a user can interact with an app. This means that the view controller class is the gateway through which a user can interact dynamically with an iOS app's UI. One class in an app will be specified as the main class. This is the entry point from which iOS will run its program, as it's the first screen that appears when a user launches an app. When you create a new iOS project using the app template in Xcode, a file called appdelegate.swift is generated with some initial code alongside other generated files and folders. Let's preview this generated appdelegate.swift file in Xcode. I've generated a project called Video Player using a project template. As a result, there are different folders and files available within the Video Player project folder in the navigation bar on the left-hand side. One of the generated files is the appdelegate.swift class. To view the appdelegate.swift class, I click on the appdelegate file in the navigation bar. The code snippets generated when I created the Video Player project are displayed in the document reader. The purpose of the annotation @main is to inform the compiler that this class should be the entry point of the application. Adding this annotation means that you want the appdelegate class to generate a main function that will serve as the entry point of your app. This is the purpose of the appdelegate.swift class. Notably, the main function is generated automatically as you have the @main annotation added to your class. Next, let's explore the view controller. To view this class, double-click on View Controller in the navigation bar on the left-hand side. As mentioned earlier, the code displayed in the document reader was generated when I created the Video Player project. The View Controller is where you're going to write the code for all the functions that will manage the interactions of your users with your application. In later lessons, you'll learn how to use the View controller to start building interactive applications and, of course, App Delegate as the entry point for your app. You have now been introduced to View controller classes and the main.swift class. You've also previewed the main.swift code in Xcode. As you progress with your learning, you will discover how to use main Swift and View controller classes to create different classes and build an interactive app. Have you ever wondered how Xcode compiles and runs an application project with different files and folders? Well, this is done with the help of the Xcode build system, the subject of this video. With the build system, the iOS project is managed through a set of build configuration files. This includes defining how a project is to be developed, what dependencies need to exist for the project to build and run successfully, and what the result or results of the compilation process should be. To start using the build system in your app project, you don't need to install anything, as it comes with Xcode by default. When you click the Run button on the Xcode toolbar, this action automatically triggers the build system activity, which in turn starts building the project. After a successful operation, your app starts running on a simulator or a physical device connected to the computer. Currently, you, as a developer, can select your preferred build system from the Xcode IDE. There are two build systems available in Xcode: the Legacy and New build systems. Legacy is Apple's first build system. It was initially developed to help developers build, run, and deploy their apps to the App Store. The Legacy build system will be removed in a future release. To improve the developer experience, Apple released another version of the build system called the New build system. It provides improved reliability and build performance, and it catches project configuration problems that the Legacy build system does not. With the Xcode build settings, you can control the build phases in order to generate a product, also referred to as an app. It is essential that you are familiar with these settings, as it will help you gain knowledge of how specific operations will be performed. Also, if you encounter any type of build errors, your first go-to will always be the build settings. Let's examine some of the sections under the build settings of Xcode. Every device in the market operates on a specific central processing unit or CPU architecture. This means your app will only work on a device if you have configured it for that type of device. The Architectures section helps you to have control over which type of device architecture your app should support. In this section, you specify the architectures your application will support. When you install an app on a device, it usually displays the name of the app on your device. With the Packaging section, you can specify the name of your application or product. The Deployment section describes the targeted device family, meaning you can specify which devices your app supports. iOS Deployment Target explains the minimum deployment target your application is going to support. For example, you may want to support iOS 10 and above. You should now know more about the role of the Xcode build system and how it is used to build and run projects in Xcode. To provide a better experience for users, iOS and macOS rely on the presence of special metadata in each app or bundle. This metadata is used in several ways. For example, imagine you want to define and use some configurations, such as limiting the allowed orientations for your app. You want to have these configurations in one place so that it's easy to access them. In Xcode, you can use the info.plist file to do this. This way, the app provides its metadata to the system. In this video, you'll explore the info.plist file. You can start by clicking on the info file in the project folder. Notably, the info.plist file is usually generated at the point of creating a new project. This file is where you can store information about your app and configure a number of things. It has a key and a value, as well as a type. The keys and values in the file describe the various behaviors and configuration options you want applied to your app bundle. The type refers to the type of value you are storing. Let's consider a use case scenario for info.plist. For example, imagine that you need to use a camera in your application. You will need to specify a privacy setting within the info.plist file in order to notify the app that it must request permission from the user before the camera launches. To do this, you can right-click on the black portion of the screen and click Add Row. A long list with different configurations that you can specify within the info.plist file is displayed. For example, imagine that you need to use a camera in your application. So if I choose Privacy, there are many privacy options. Let's select Privacy Camera Usage Description. As mentioned earlier, this implies that at the point of running your app, the camera will not function until the app has requested whether the user wants to access the device. The same applies to using contacts in your application. If your app wants to pull the contact list from the user's device, you need the user's permission before you can access their contacts. You can configure these privacy settings in the info.plist file with the Privacy Contacts Usage Description configuration. It is a general rule or standard to specify various privacy settings when it comes to building iOS applications. If you don't specify these things in the info.plist folder, your app will be flagged by Apple and then rejected. Aside from privacy, you have access to a long list of other things you can do. For example, you can define the bundle identifier and specify a bundle name and bundle version. When you specify these values, you can uniquely identify the build and release for a particular app. This is what the info.plist is meant for. Hopefully, you'll be able to use the info.plist file to specify app configurations or push the permissions required before your app can go live in an app store. When you develop an iOS app, you may need to add resource files such as image files, audio files, data files, and more. It is therefore essential that you are familiar with the way files are imported to an Xcode project from the IDE. In this video, you will learn how to add and manage these files. The first step is to open an existing Xcode project. In this example, the video_player project is displaying. Right-click the Xcode project folder called video_player. Select the Add Files to Project Name menu item from the pop-up menu list by clicking on it. In this example, the project name video_player displays in the menu item. Next, you have to select one or more files that you want to add to your Xcode project. In this example, the video file called test is selected. You can check the Copy Items if needed checkbox in the Destination section to copy the added files to your target iOS app project. If you do not check this checkbox, the file will not be copied into the target iOS app, which means your iOS app will not work properly. Because we are not adding folders, you can select any radio button in the Added Folder section. The Added Folder section is only useful when you add folders to your Xcode project. Select one target by checking its checkbox in the Add to Target section. Then click the Add button. To verify that this file has been added to the list of files that will be copied when you generate the app, click on the root project. In this example, video_player is the root folder. Then click on the project under the Target section. If your file displays under Copy Bundle Resources, it will be exported with the app. You have now learned how to add files to an Xcode project. You should also have more insight into how to manage these files. Building an iOS app project means that you will need to work on the multiple files necessary for your app to run on a device. In order to ensure that these files are well organized and readable, Xcode automatically provides you with a project structure made up of various folders that manage all these files. In this video, you will explore different folders that are generated at the point of creating a new project in Xcode. In the project window on the left-hand side, there are three major folders right inside the root folder, hello_world. The root folder is the main project itself, or the iOS project. From the root folder, you can configure some things. For example, if you click on the General tab, you can define the display name of your project, the bundle identifier, version, build, and other things that you would need for your project to run. You can also sign your application. This means that you want to start running the app on a device. However, before you can deploy your app, you must link an Apple account to it. There are even more tabs such as the build settings, but the details of these is beyond the scope of the current video. The first subfolder of the root folder is where the core of your app is located. As such, the features, functionalities, design, and user interface of the application will be stored within this folder. There are some files within this folder that have already been generated, including the info.plist file that you learned about earlier. These files are classes such as AppDelegate and SceneDelegate that you need to get started with development. You can add your resources and files, such as videos or images here. This is also where you'll create your storyboards and have your visual user interface. For example, if you click on the launch screen file, it displays a storyboard UI. The same applies to main. The purpose of the second folder, Hello World Tests, is for you to run unit testing. Unit testing is the ability to independently test functional features or functional code that you've written or built, ensuring there are no bugs or issues. The third folder, Hello World UI Tests, will enable you to test the interactions between different elements on your user interface. This is to ensure that the behavior of your user interface meets the requirements of the client, for example. You have now been introduced to the 3 major folders that are generated when you create a new app project in Xcode. You have completed this module on simulation and development. In the module, you've discovered iOS simulators, including operating system versions. You've also examined the project structure of an iOS app, learning more about iOS code. Now let's recap the key module takeaways. You began the module with an introduction to simulators. Following the completion of this first lesson, you can now discuss simulator software, including what simulators are, what simulators do, and some examples, and demonstrate how to set up and start a simulator in Xcode. You were introduced to the architectures you can choose for the simulators and simulator operating system or OS versions and images. You also learned how to access these OS versions on the simulator, in preparation for running and testing your own app project using a simulator later in the course. In addition, you should now be able to discuss the types of simulators available in Xcode, describe interface of iOS simulators, as well as outline the common libraries and packages available for you to use in your app project. Once you completed your study of simulators, you then moved on to explore the topic of iOS code and project structure. Now that you've completed this lesson, you're able to outline the structure of an iOS project in terms of folder structure and identify and describe the files and folders that make up an iOS project in Xcode. You were introduced to the app delegate class and previewed the Swift code generated in the app delegate file in Xcode. You learned about the view controller and its role in user interaction with an iOS app's user interface or UI. You should be able to explain the role of Xcode's build system and how it is used to build and run projects in Xcode. Discuss the info.plist file in Xcode and its role in specifying app configurations. And outline the resources contained in the resource folder and demonstrate how to add these files to an Xcode project and manage them. Finally, you had the opportunity to examine the project folder and files that are generated when you create a new project in Xcode. You should be able to identify the major project folders based on their functions and contents. You're now familiar with iOS simulators and code and project structure in Xcode. Great work! You're making good progress on your journey towards becoming an iOS mobile app developer. When developing a new app, it's important to begin with project planning. The decisions you make before you start to code your project will determine to a great extent the amount of time you spend coding or manipulating libraries or packages. In other words, efficient and effective app development depends on project planning. In this video, you'll learn about an essential step in project planning: requirements gathering. Project planning starts with getting a clear picture of what the project, or in this case the app, is going to do. A clear idea allows you to break the app down into principal components of functionality, which is also known as requirements gathering. Whether the app is for you or a client, requirements gathering is a critical step that must happen during project planning. Let's work through a brief requirements specification for an app that's going to play a video. As mentioned earlier, first you need a clear idea of the app project. The idea in this case is to create a video player, but there are many ways to play videos. So you need to think about exactly what you want your app to do, asking yourself questions to help guide you and determine the components your app will need to make your project idea a reality. For example, are you going to build the video player yourself, or will it be a video selection app that sends the user to another app to play a video? Will the app store videos on the device and in what format, or will they be streamed? How will you control the video tracks? Questions like these give you the opportunity to consider different options and, as you may already be able to tell, the answers will likely guide the development of very different apps. Let's say you decide to build the video player, which will be a self-contained app. You want the video stored locally using a single file type, MP4. You also want each video track to be controlled with play and stop controls. You know now what you want your app to do. Select a locally stored list of MP4 files with controls for each video to play and stop. With this information, you can now plan and decide what platforms you want to use to develop the app and the libraries or packages needed to achieve this functionality. In this case, you'll use iOS as a platform. The advantage of a clear, planned approach is less time on the keyboard. With planning, you can speed up development considerably, instead of guessing as you go. In this video, you learned that regardless of the app you are trying to build, how you approach development is very important. The correct approach starts with planning in the form of requirements gathering. This involves answering as many questions as possible to determine the necessary components. The more complex the project, the more questions you'll need to answer. But even a simple plan like the example covered in this video will save you a lot of time and effort when developing your app. Once you have determined the requirements of your app project, you will need to explore the development of your app using a technical approach. Building an app from scratch can be difficult and time-consuming. However, there is a wide range of project templates available to you in Xcode to make the app development process easier. Using the example of the video player app introduced earlier, you may recall that the app requirements are selecting videos from a locally stored list of MP4 files with play and stop controls for each video. Bearing these requirements in mind, the next step is thinking about creating this video player from a technical development perspective. Part of this is considering what built-in controls you can use to speed up app creation. So, what is needed from a development perspective to create the required components of the video player project? Well, so far, you know that the app will be lightweight, as you don't need images, music, or video streaming. Because streaming is not required, you can use iOS AV Player to display a video file. You can use clickable buttons to create the play and stop buttons you need for loaded videos. The same can be done to include an additional button for users to select a video from the phone library. By selecting a suitable template in Xcode, you will be able to incorporate these app elements with just a few changes to the default build pattern or template. Using a template is a major advantage, as the process of setting up your video player app project with its main features will be quicker and easier. Let's explore some of the project templates available to you in Xcode. You learned that Xcode is an integrated development environment, or IDE, used for developing apps for Apple devices. In the project template window of the development environment, I've selected iOS as the project platform. When creating a new project, you are presented with a wide range of templates that provide starter code for various basic implementations of the iOS platform in this window. The available templates include app, document app, game, augmented reality app, sticker pack app, iMessage app, and Safari extension app. You can use each of these templates for a specific purpose. I need to select a template that is suitable for the example project, which is a video player. Because the video player will be a standard application, I'd recommend selecting the app template. This will generate a base code for the video player that includes commonly used user interface or UI components that you may need for the project and will get you started with development. You can then add more code to perform specific actions based on the project requirements. Later, you'll learn in greater detail how the app template can help you build your video player efficiently and effectively. Now that you know how to choose a suitable template for your app, you can think more seriously about starting your project, which is the next step. Good luck. You are ready to start creating your video player. Now that you know what the requirements are and you have your project plan in place, you can launch Xcode and start coding. Let's get to work. You'll be creating a new Xcode project, which is an option available to you in the Welcome to Xcode window. After selecting the Create New Xcode Project option, a window pop-up displays, prompting you to choose a template for your new project. There is a wide range of project templates available to choose from. To start your new project, select an app template. This will allow you to create a base code for your app that includes commonly used user interface or UI components. This will form a base project to which you can add more code. Next, the system prompts you to select options for your new project. To create a new project, you must complete the following steps. First, you need to provide your new project with a project name. Let's call it video_player. Every iOS app has an application ID. This ID uniquely identifies your app on the device and in the Apple Store. Once you publish your app, you should never change the application ID. If you want to upload a new version of your app, the application ID needs to be the same as what it was when originally published. If you attempt to make changes to the application ID, the Apple Store sees the deployment as a completely different app. So let's create a unique organization identifier and call it Conan. The bundle identifier will automatically be generated as conan.video_player. Select either SwiftUI or Storyboard from the interface drop-down menu. For this project, you are going to use Storyboard throughout. Next, select either Swift or Objective-C from the language drop-down menu. For this project, you are going to use Swift language throughout. Finally, you click on the Next button. Here is your new video_player project. You now have a basic view controller class which will be used to display the user interface of your video player to the user. Apart from the view controller class, there are other files and folders that are generated alongside it. You've already learned about those in previous videos, so you're ready to move on to the next step, which is to learn more about AV Player. Let's keep moving. Have you ever used an app and found it better to use than another one of its kind? But what makes one app better than another? Well, creating an intuitive and simple design that's easy to navigate is essential in delivering a satisfactory user experience. To achieve this experience in iOS, you have access to a wide range of components called views. In this video, you'll learn more about the different views available to you and how you can create a user interface or UI with them in Xcode. So, what are views? Views are the fundamental building blocks of your app's user interface or UI. In other words, the UI in an iOS app is comprised of a collection of views. Text, images, and buttons are all views in iOS. You can create views using Swift code or an Xcode storyboard. The behaviors that are common to all views are defined by the UI view class, which is iOS's built-in view class. The UI view class is designed to hold one or more UI elements that will appear to the user and manages the content for a rectangular area on the screen. It is ultimately responsible for displaying information or content and event handling. Generally, iOS apps will contain one or more view controllers, where each view controller is one screen of the app. The controllers will contain one or more UI components, and those UI components are instances of view. View controllers are fundamental for your iOS app as they govern what happens on screen, from UI and animation to interaction to navigation and the many steps in between. There are various views available in Xcode for implementing UI in your app. They have distinctive designs that you can select based on the requirements of your app. Let's explore a few of the commonly used iOS UI views. Scroll view helps you to display content that is larger than the size of the screen. It can contain all the other UI elements such as image views, labels, and text views. You can use table view if you need to vertically display one or more reusable elements in a scrollable manner. This consists of many cells and has special features such as headers, footers, rows, and sections. Split view will help you manage two views side by side, a master on the left and a detailed view to its right. This is useful when you want your app to be responsive on an iPad. Now let's examine how these UI views are used within an Xcode storyboard called main.storyboard. I'm going to demonstrate how to create a main.storyboard file. You will use this to create your user interface or UI components. The project folder for the project I generated previously, video_player, is on the top left. To create a new file, you can right-click and select New File. A window appears where you can choose from a variety of file formats. The focus of this video is UI, so let's select the storyboard format from the user interface options. You can then click on Next. Another window will pop up. In the Save As section, you can change the name from Storyboard to Main. You can leave the other default settings for now and click on Create. The storyboard is now displayed. This is where you are going to add new components. To illustrate, let's create a scroll view, which you learned about earlier. This will enable access to the library of UI components such as text, button, scroll view, and other UI components that you need to create an app. You have the option to select these components from this environment or to use a shortcut on your keyboard. To use the environment, you will need to click the plus button, which represents library, located on the top right of this environment. If you click the plus button, a window that offers a variety of UI components for development opens. You can choose from a wide range of components, including a switch, activity indicator view, page control, text view, scroll view, date picker, and more. And that's how to access your UI components using the environment. The other alternative is to use your keyboard. If you select Command-Shift-L on your keyboard, this will also open the library. Now let's select Scroll View by double-clicking on it. This generates the Scroll View UI component, which you can drag and place where you'd like it to be displayed on the main storyboard we created earlier. You can adjust the height and width depending on what you want to do with the scroll view. You now know how to create a UI component in your main.storyboard file. Soon, you'll be able to use a main storyboard to create your first video player app. In this video, you learn more about views and common types, as well as how they are used within Xcode. Views are an integral part of building the UI for your iOS mobile apps. The video player app that you are creating will need to access the video files a user wants to play. With the help of iOS's built-in bundle.main.path, you can locate these assets. Bundle.main.path is a function that you use to identify a resource. This function identifies a resource either by location, name, or both. Let's open Xcode and explore how to locate a resource, in this case a video file, with bundle.main.path. I'm going to demonstrate how to add a new video file to your Xcode project. Using the earlier example of building a video player, I will add an MP4 video to an MP4 video writer in this project so that I can play a video. I will then show you how you can use bundle.main.path to access this file in your Swift code. To start, I'm going to drag a new video file and drop it in the video player project folder. A window pops up with the options for adding the file. Although it gives you the option to create a folder resource, there is no need for Xcode to create a new folder for the video file, as you can use the video player folder. So I select video_player next to add the project to the target folder where all the project code resides. Then click Finish. The video entitled Test is added to the video_player folder. Now that I have added the video to the project, I need to confirm that this video is going to be exported at the point of deploying the application. To do this, I click on the main Xcode project or the root folder, also called video_player. From the Targets pane, I select the video player, which displays some tabs. I expand the Copy Bundle Resources tab. This is where your files are bundled. Here, you need to check that the video file added earlier is included in the resources that will be bundled at the point of building the application and running it on the device. The video file, test.mp4, is displayed here, which means that it has been added to this folder. If, for some reason, you do not find the file you added within the Copy Bundle Resources, you can click on the plus button and add the file manually. Now let's go to View Controller to preview the code needed to access that file. Click on the View Controller file. You may recall that the View Controller controls the behavior and then presents the logic and the interactions of the user interface. So this is where you need to write the code that will find the added video for you. I'm going to create a new function after the override function. I type private to call it private and func, which means you are declaring the code as a function. Then find video open and close two pairs of braces. You will write the code within the last pair of braces, the code that finds the video. There is an error as I have used else within the function. Ideally, if you want to use this conditional statement with this variable declaration here, you must use the keyword guard. The guard keyword allows you to check a particular statement. If it's valid, then perform the next operation. If not, then just throw an exception. This will remove the error. There is also a warning, which states that the path has not been used. Usually, this path is supposed to be used by another line of code. It hasn't been used in this case because I declared the function early without writing other code to demonstrate how you can access the video file. Lastly, within the path, I need to change the name of the video resource, which follows on from for resource, from video to test. When you learn how to create a video player using the bundle.main.path, you should be able to add new files to your Xcode project and locate them. You should now be familiar with how to create a video file in an Xcode project and how to reference files saved in this folder from within your Swift code. You can look forward to playing video files in the video player application you'll create later. As a developer, creating an app from the start can be difficult and time-consuming. With a single import statement, Swift makes a class or classes for a built-in package within the iOS Software Development Kit, or SDK, visible. This is useful for developers as you don't have to write your app projects anew. In this video, you'll learn about the imports you need for your video player app project. For example, to speed up development, you can use an AV Player class that has already been added to iOS's SDK. To access this class and other helpful ones, you can reference it by using an import statement. The statement import AVKit implies that you want to use the AV Player class that's included in the iOS SDK. Now let's explore in more detail imports you can use for your video player app project. I'm going to introduce you to the imports you'll need to build your video player app. Within the video player project in Xcode, you can click on the View Controller file in the project navigator on the left-hand side. As you learned previously, the View Controller is where you write the Swift code that'll help you interact with the app user interface, or UI. In the View Controller Swift class, you have three major imports. The first one is UI imports. This provides you with the window and view architecture that you need to implement your interface. It gives you control over your UI from within the Swift class. The second import is AVKit. AVKit helps you to create interfaces for media playback, which will enable you to create the interface for your video player. The AVKit has an inbuilt AV player that you'll make reference to in order to load or play a video. The last import, AV Foundation, gives you control over different things such as device cameras or processing audio. For your video player app, you'll need to be able to process videos. The AV Foundation helps you configure the audio and video interactions within your UI. It has inbuilt functionality that helps you to manage those interactions in real time. Whereas the function of AVKit is to help you create the UI so you can play a video, the AV Foundation manages the overall interactions of your video and the operating system itself. So, UIKit, AVKit, and AV Foundations are the imports required for your video player. Note that you will write all your code within the UI View Controller class, which is located beneath the imports. You should now have a better idea of the major imports you can use to speed up the development of your video player app. Later, you will start building the app itself, writing the code and ensuring video files will play on your video player. In a previous video, you pondered the question of why some apps are better than others. Here is another reason: interactivity. Users want to interact with apps that can understand and remember what they want to do. Interactive apps create a great user experience. That's why you need to be able to manage user inputs effectively. With Swift, you can store data temporarily using variables. The data stored as variables can be changed and reused depending on the condition or on information passed across the application. To declare a variable in Swift, you can use the keyword var. Let's unpack the syntax. Var implies that you are creating a variable. Next is an identifier called variable name, followed by an equal sign, and finally the value, which is stored in the variable. Swift provides a set of built-in variable types that represent numbers, such as integer or int for short, and string. The integer data type holds numbers, while a string is a collection of characters. In this example, total count is an integer variable and has a value of 25. In this example, country is a string variable. But what do you do if you, for example, do not know the country? Well, fortunately, you can declare a variable without assigning a value right away. However, this is only possible when you specify the variable type. Let's declare a variable with an identifier called color and set the data type as string. Because Swift now knows what type of variable it will be, you are allowed to assign the value of color only in the next line. Now let's focus on type annotation when declaring a variable. When you declare a variable without including the data type, such as integer or string, Swift automatically does that for you using the data type of the initial value. When you declare a variable as a string, Swift forces you to only assign content that matches the data type specified. For instance, say the variable country was created using string data type and a value of United States was assigned to it. If you try to assign an integer value of 4 in the next line, Swift will generate an error. Lastly, let's focus on how to display variables on screen. To perform special tasks such as displaying a variable, programming languages use something called functions. In Swift, to display a variable on screen, you use a print function. To write a print function, you type print followed by a set of parentheses. You then add the value that you want to display on screen in between the parentheses. Let's explore a few examples of print functions. In this example, the variable first name has the value of Michael. If you include the word hello between quotation marks and first name in the print line function, then hello Michael will display on screen. Now let's include two additional variables, last name for surnames and full name to combine the first name and last name. Notice that a plus sign can be used to combine the values of two string values as a single string. The print function now displays the first name and the last name on screen. In this video, you were introduced to the var keyword, which you can use to declare variables. You also learned about different types of variables and how you can display them using the print function. It will be used to display a video file in your application. You will need another component named AV Player View Controller as well. It will provide you with the playback controls of video player, such as play, pause, backward and forward to control the video player. And with the combination of AV Player and AV Player View Controller class, you will be able to create your video player. Now let's move on to what you need to do to actually create your player. Previously, I created a project called video_player in Xcode. I also added a resource called test to this project. This is a test video. Let's continue this project creation process by creating a simple video player that can play and pause the test video. Before jumping into coding, take note of main in the project navigator on the left-hand side, which is the main storyboard for your app's user interface, or UI. This is where the video player for your app will display. Now, to add functions to the video player, you can go to View Controller in the project navigator. As you've learned earlier, the View Controller contains three major imports: UIKit, AVKit and AV Foundation. The View Controller class is where you write the Swift code that will help you play the video. The first function you need is an override function. The purpose of this function is to initiate the player once the app is launched. To create the override function, you can write override func and then view did, selecting view did appear from the options provided. On the next line, write super.viewDid, again selecting view did appear from the options. Enter twice and then give the function a name by typing play video, followed by an open and a closed brace and a semicolon. An error message stating cannot find play video in scope displays, as you still need to write the play video function. To do this, on a new line, write private func play video, followed by two sets of braces. Within the second pair, you can press enter to move to a new line. Then specify the location of the video. To do this, type the keywords guard, let and path directly followed by an equal sign and bundle. When you press enter, the code that traces the file displays. The main path is indicated as test and the file type as MP4. The keyword guard is used to check if the video file exists. If it does, the value will be passed to path and the video located. If the file does not exist, the error message after test.mp4 not found will be displayed. Now that you have specified the path, you have to add code to initialize the AV player. The AV player is fundamental to creating the video player. To initialize the AV player, you use a variable. On a new line, write let player equals AV player and press enter. Note that you are using the class from the AV kit that was imported by default as part of the package. If you remove the AV kit import, the AV player will no longer exist. Next, you have to add a player controller. The purpose of this controller is to help you create a user interface where a user can play, pause, fast forward and rewind. There is a controller called AV Player View Controller that comes with the AV kit. To add this controller, on a new line, enter let player controller equals AV Player View Controller and press enter. Now you have access to all the properties and functions that come with an instance of the AV Player View Controller class. You then need to link your player to the player controller. On a new line, write the following: player controller dot player equals player and press enter. This line sets the display to the specified controller. Lastly, you must ensure that the player itself displays. You can use the present function to display the player. On a new line, select the present function, then define the controller by entering player controller directly after the open brace. If you want it to be animated and seamless, set the animated option to true. The last line of code in the present function, player.play, calls the play function, which ensures your video plays. If this line of code is absent, your video will not play. And that's in essence what you need to run a video. To view the output of your code, click on the Run button. A message, Build Succeeded, displays, followed by your simulator playing the test video. On the simulator, you can pause or play the video. You can also scroll through the video or mute and unmute it, as a user would when using your video player. You should now be able to create your own video player app in Xcode. Well done! I hope you enjoyed this walkthrough of the process of creating the video player. Now it's time for you to give it a try. Well done! You've reached the end of this module on iOS mobile app development. Let's recap the key points and skills related to building a mobile app in Xcode. You began this module with a lesson on the requirements gathering process and its role in project planning and creation. You learned that solid project planning is crucial to efficient development of effective apps and should now be able to execute basic project planning. You then moved on to explore the project templates available to you in Xcode and selecting a suitable template for your video app player. Having completed the lesson on starting the project, you should now be able to recall and perform the steps to create a base project using a template on Xcode. You were introduced to the AV player, which is used to play media assets like video files in a video app player. Following the lesson on setting up the screen, you should now be able to explain the function of views, the UI view class and view controllers in relation to an iOS app's user interface, and describe commonly used UI views and how they are used within Xcode. Also related to user interface, you read about using Storyboard and SwiftUI to create the user interface for your app in Xcode. You then learned how to add assets in Xcode and use iOS's built-in bundle.main.path function to locate these resources, such as video files, and use import statements to help you leverage the iOS Software Development Kit, or SDK, to speed up app development with a focus on major imports. You were subsequently introduced to the keyword var that you can use to declare variables in Xcode. You also learned about different variable types and how in Swift you can display variables with the print function. Finally, you had the opportunity to use the knowledge you've gained to follow along and create a video player app that can play and pause a video player. You should now be familiar with the essential skills and concepts of iOS mobile app development and should be able to create your own video player app in Xcode. Congratulations, that's great progress toward becoming a skilled iOS mobile app developer. In this course, you were introduced to iOS mobile app development. Let's recap what you learned. In the opening module, you had an introduction to the program and course. You gained insight into the roles and responsibilities of mobile developers, from designing, building and maintaining mobile apps to project planning and research, and discovered development essential skills like knowing programming languages. Whether you work for a company or freelance, you explored various career roles that you may follow as a mobile developer. You also reviewed tips on taking this course successfully and discussed what you hope to learn. You then downloaded and installed the development environment used for developing applications for Apple devices, Xcode, in preparation for developing your own iOS app. You were introduced to mobile apps, mobile operating systems, and iOS platforms such as iPhones and iPads. In the last lesson, you learned more about iOS programming languages, focusing on Swift, the preferred language for building iOS apps. You discovered Xcode project templates, which provide base code that help developers build functional apps more efficiently. You also toured Xcode, learning about the features such as a build system and functions such as the navigation and editor areas that improve app development. Then you followed a quick guide to starting your first iOS project in Xcode and unpacked its structure, learning about 4 major components: UI application, UI application delegate, UI document, and view controller. You began Module 2 by exploring simulators, the computer programs designed to simulate other devices. You learned that they allow you to test your apps on the devices they've been designed for without needing to install them on a physical device. You were then guided on how to configure and launch a simulator using the Devices and Simulators feature in Xcode, and later examined the interface of an iOS simulator. You explored the wide range of pre-created simulators available and how to create your own, selecting the device type and iOS version you want to simulate. You were also introduced to the Simulator Operating System, or OS versions, which are versions or images of iOS that make it possible for you to run apps using a simulator, and how to access them. You examined the structure of an iOS project in Xcode, learning about the folders and files that contain everything required for an app to run, from source code and assets to test code and build configurations. More specifically, you explored the project folders in Xcode, including the root folder, project tests folder, and the UI test folder, and later in the module, their functions. Functions include configurations, locating the core app, running unit testing, and testing interactions between elements of your user interface, respectively. Next, you learned about the app delegate class, which is used to generate a main function that serves as the entry point of your app. After that, you were introduced to Xcode's build system, which is fundamental to building and running projects in Xcode, and vital build settings. You learned that the info.plist file is used to store information about your app and its configurations, and how to import and manage resource files in the resource folder of an Xcode project. The final module guided you in setting up your project in preparation for building a video player app. You started by exploring the importance of project planning and learned how to perform requirements gathering to develop a detailed idea of what your project is going to do. You then explored how to use this to determine which built-in controls, like project templates, you can use to build your app more efficiently, and followed along to create a base project using a template in Xcode. You used the UI view class to define the behaviors of views, the fundamental building blocks of your app's user interface, or UI, and create the UI components that appear when users launch your app. You were also briefly introduced to different ways of building your app's UI, storyboards, or SwiftUI. After that, you observed how iOS's built-in bundle.main.path is used to locate and access a video file in an Xcode project, and learned about the imports you need for your video player project. Specifically, you were introduced to UI imports, AVKit, and AV Foundation and their functions. These were the major imports in the view controller Swift class to speed up development of your video player app. You learned that you can store data temporarily using variables with Swift to create interactive apps that remember and understand what users want to do, learning about different variables, declaring them and displaying them with the print braces function. Finally, you had the opportunity to follow along and create and launch your own video player app in Xcode using the AV Player and AV Player View controller. Well done. You have covered many concepts and skills and gained significant knowledge related to iOS mobile app development during the course of your learning. Now you're ready to try out what you've learned. Good luck. Congratulations on reaching the end of this course. You've worked hard to get here and developed a lot of new skills. You're off to a great start with your mobile development journey and your improved understanding of iOS mobile application development. You were able to demonstrate some of this learning and your practical app development skill set by creating your own video app player in Xcode. Now that you've completed this course on iOS mobile development, you should be able to describe the general principles of mobile apps and the iOS Xcode platform, discuss simulators and the elements of project creation in Xcode, and demonstrate how to create and modify a video player app in Xcode. So, what are the next steps? Well, this course on iOS mobile application development forms one part of the iOS Developer Professional Certificate. Although you've covered several key areas, you probably realise that there's still more for you to learn. If you found this course helpful and want to discover more, why not register for another? You'll continue to develop your skill set during each of the iOS mobile developer courses. In the final capstone project, you'll bring together and apply everything you've learned throughout the courses. Whether you're just starting out as a technical professional, a student, or a business user, the course end projects prove your knowledge of iOS mobile app development. These final labs consolidate your abilities with the practical application of your skills. But they also have another important benefit. It means that you'll have a mobile app that you can reference within your portfolio, which will demonstrate your skills to potential employers. And not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. Once you've completed all the courses in this program, you'll receive certification in iOS development. This certification can also be used as a progression to other role-based certifications. Depending on your goals, you may choose to move on to advanced role-based certifications or take other fundamental courses. These certifications provide globally recognized and industry-endorsed evidence of your technical skills. Thank you. It's been a pleasure to embark on this journey of discovery with you, and best of luck in the future.